What's up, Matric? Welcome back to another video. In this video, we will be talking about the quadratic sequence. It is not the first time you hear of the word quadratic or quadratic equation. Quadratic equations or quadratic has been introduced to us from our grade 8, where we have been introduced on how a quadratic formula could look like, and we were told that the quadratic equation usually has the highest power of 2. Okay, and then we also know that a quadratic equation has a form of an squared plus bn plus c. It could be ax squared plus bx plus c. It doesn't really matter what letters are here, but the only thing that matters is it has a highest power of 2, and then it is in the form of an squared plus bn plus c. Okay, but in this video we will focus on the quadratic sequence. What is a quadratic sequence? Let me just start with the quadratic sequence and actually talk about what makes a quadratic sequence actually spatial, because in the previous videos we were introduced to geometric sequence or arithmetic sequence, where we were told that the arithmetic sequence has the first constant difference the first difference should be constant, and we were told on the geometric sequence that it has a constant ratio. But what makes a quadratic sequence spatial? It is written here that the quadratic sequence, it is a sequence of numbers in which the second difference is constant. Okay, so a quadratic equation or a quadratic sequence, it is a sequence of numbers where the second difference is actually constant. Let me introduce some numbers and let's find out how we're going to get the second difference to actually be constant. Okay, for an example, let's just have the formula here. If we're looking for t1, right, then I have t1 is equal to a1 squared plus b times 1 plus c, where we have a plus b plus c. That's t1. Okay, if we're looking for t2, I just need to write it. T2 is equal to a and squared plus b and plus c, where we can actually put a 2 here, squared plus b2 plus a c. Okay, then we know that t2 is equal to 4a plus 2b plus c. Okay, if we want to get t3, okay, the third term of the sequence, then we have an squared plus bn plus c. Then we have a times 3 squared plus b times 3 plus a c. Then we have 9a plus 3b plus a c. Okay, if we want to introduce term 4, then we have an squared plus bn plus c. Okay, then we have a times 4 squared plus b times 4 plus c. Then we have 16a plus b plus c. Okay, so we are introduced to term t1, t2, t3, and t4. Okay, so we can just write them down. So we know that t1 is a plus b plus c. We know that t2 is 4a plus 2b plus c. And then we know t3 is 9a plus 3b plus c. And then we know t4 is 16a plus 4b plus c. Okay, so these are the terms that we have here. So we have to find their differences. Okay, we know that in order for us to find the difference, it's usually t2 minus t1, or t3 minus t2, or t4 minus t3. Okay, when I try to get the difference here, and here, and here, okay, then for the first difference here, I get 3a plus b, 4a minus a is 3a. 2b minus a b is a b. C minus a c is a 0. Okay. For the second difference, then I get 5a plus a b. 9a minus a 4, it's 5a. 3b minus a 2 is a b. C minus a c is a 0. Then I get 7a plus a b. 16a minus a 9 is 7a. 4b minus a 3b, it's a b. C minus a c is a 0. So we have noticed that from getting the first difference that the first difference isn't actually constant. The first difference of the arithmetic of the first difference of quadratic sequence is actually not constant. So we have to go through the difference again and see if the second difference is actually constant. Okay. Okay, so 5a minus 3a, then I get 2a. b minus b is 0. 7a minus 5a, then I get 2a. Okay, from looking at this formula here, we have noticed that the second difference of a quadratic sequence is actually constant. Okay, so what actually makes quadratic equation very special is the fact that the first difference, it's actually an arithmetic difference. When we took the terms that we have, getting the first difference, it gives us an arithmetic difference, and then after that, then we have a constant. We know from the previous video that once we have an arithmetic sequence, then arithmetic sequence usually has a constant difference. So we could say that a quadratic sequence, the first difference of a quadratic sequence is actually an arithmetic sequence. I hope that is making sense. Okay. So now we can take examples and where I'm going to explain everything properly. Okay. Okay. We're going to take an example from the November 2021 paper 1 question 2. Okay. It says that consider the quadratic sequence 72, 100, 120, 132. And then question 2.1.1 say determine the the nth term of the quadratic sequence. Okay, we need to determine the nth term of the quadratic sequence. So we first of all, when I look at a question like this, when I'm given at an exam, the first thing that I have to do is, and I have to make sure that, okay, let me take my sequence and let me write it down and find the difference, find my two difference, and once my two differences gives me that the second difference is actually constant, then I have agreed. But in this question, it's actually very easy because an examiner made sure that he told you this is a quadratic sequence, okay, meaning you will know that the second difference must be constant, and once your second difference is not constant, then there is something wrong with your differences. Okay, so let's go through it. Question 1. I'm given 72, 100, 120, 132. Okay. Now I need to find the difference. Okay, if I take 100 minus 72, I have a 28. Okay, if I take 120 minus 100, then I have a 20. 132 minus a 120, then I have a 12. You can notice that the first difference isn't constant, but yet bear it in mind that the first difference of a quadratic equation gives you what? An arithmetic sequence. If we have an arithmetic sequence now, then we must know that if we take the difference in these numbers, it must be constant, right? Then we have an 8 minus 8. Then if I take 12 minus 20, then I have a minus 8. It proves us that the examiner was actually right, and this is a quadratic sequence because the second difference is a constant. Okay, so we have been asked to find Tn. Okay, but we know that Tn is equal to an squared plus bn plus c. So we need to define terms like what is my a, what is my b, what is my c, in order for me to have this equation, right? So this is just a general term, and I have to define each of this term at the end of this. Okay, what should I do? If you look at what we previously did here, okay, if you look at what we previously did here, so this is our T1, this is our T2, this is our T3, this is our T4, okay? And then we know that the first differences was 3a plus b. Then our first difference here is 28. And then we also know that the second difference here was 2a. But here our second difference is actually minus 8. So writing it down over here, then I know that here I have 2a is equal to minus 8, and then here I had 3a plus b, which should be equal to 28. And then for the first term, we know we had a plus b plus c, okay, which is equal to 72. Okay, so writing this equation will actually help me determine each of this term. It will help me find out what is my a, what is my b, and what is my c. So I'll start with the last one, then I'll go up, because the last one, actually, when I do it, then I'll get a value of a. Once I've gotten a value of a, then I can just substitute here, and then from here I'll get a value of b, and then once I get a value of b, then I can just substitute on top here. Okay, so I have 2a is equal to minus 8. Divide by 2, divide by 2, then I have my a is equal to minus 4. Okay, what do I need to find? Okay, I find the a, now I need to find the b, right? So I know that I have 3a plus b, which should be equal to 28. Okay, but my a is actually a minus 4. Minus 4 plus b equal to 28. Okay, this is a 12 minus a 12 plus b equal to 28. So b is equal to 28 plus 12. So we have 28 plus a 12, which is actually a 40. Okay, our b is a 40. Okay, this is how easy it gets. We defined the a, we defined the b, so now we need to find the c. And then we know that in order for us to find the c, we have a plus b plus c, which is equal to 72. Okay, because we know that our first term was equal to a plus b plus c. Okay, but we know what is the a, we know what is the b, but we don't know what is the c, which makes this actually very easy to solve. We know that our a, we previously found it as a minus 4, and then our b was a 40. Okay, so we just need to put it through this equation here and solve for c. So we have minus 4 plus a 40 plus a c equal to 72. Then we have minus the 4 plus the 40 plus the c equal to 72. Fuck. Why did you mess up? I don't know. So now we have to get it out again. Okay, so we know that we have our a, which is equal to minus 4, and then we have a b, which is a 40. Okay, then we just need to put this into the formula and actually solve for c. Okay, if we put that, then we have a minus 4 plus a 40 plus a c equal to 72. bringing every term to the other side, then I'm left with c alone. Then I have 72 plus a 4 minus a 40. Then I have 72 plus a 4 minus a 40, which I get 36. So c is equal to 36. Then we have our a, which is a minus 4, our b, which is a 40, and our c, which is a 36. And therefore, we can just plug it into our general formula for the quadratic, which says a is n squared plus bn plus c, which is equal to minus a 4 n squared plus a 40 and plus a 36. Tn is equal to that. Okay, that's what you have been asked to solve in the exam. Let's take the next question. So the next question says that a term in the quadratic sequence, the quadratic sequence, which we know that is 72, it's 100, is a 120, and a 132. And then it says that is equal to the 12th term of the sequence of the first difference. Determine the position of the term in the quadratic sequence. Okay, let's read it again. Let's read it again. It says a term in a quadratic sequence. The quadratic sequence, which we know is 72, 100, 120, 132, is equal to the 12th term of the sequence of the first difference. Okay. Determine the position of the term in the quadratic sequence. Okay, what do I know? I know that okay, what do I know? This is what I know, that I have a quadratic sequence that is 72, 100, 120, 132. Okay, and then I'm told that the 12th term of the sequence of the first difference. Okay, this is the first difference. Okay, so we know that T12 of the first difference. Okay, the 12th term of the sequence of the first difference. What do we know? We know that the term in the quadratic sequence is equal to the 12th term of the sequence of the first quadratic difference. Okay, so there is a term here in the quadratic sequence which is equal to T12 of the first sequence. That's what we have been told. And then we have been asked to determine the position of the term in the quadratic sequence. Okay, cool. Okay, first of all, we need to find T12. Okay, we need to know what number we're dealing with. And then where is that number in a quadratic equation? There are so many methods to actually solve this question, but I'm going to use what I think it's actually good for me and what works for me, right? So we know that the first difference of the quadratic equation is actually an arithmetic equation. Okay, what do I know from the arithmetic equation? I know that Tn in the arithmetic equation was a plus n minus 1 and the difference d. Okay, if you haven't watched this video, I will advise you to actually go back to this video and actually just see what we studied from the arithmetic equation. Okay, and then we defined terms like T1, T2, T3. So we have an equation. We have sequence like 28, then we have 20, then we have 12. Okay, and then we know that the difference is minus 8 of each. Okay, this is T1, this is T2, this is T3. So T2 minus T1 should be the same as T3 minus T2. Okay, that's what we knew from the arithmetic equation. So putting it into the equation here, we know that Tn is equal to 28 plus n minus d, and then the difference is minus 8. Multiplying it throughout, then I know 28 plus, then I have minus 8n, then I have plus 8. Okay, then I have 28 minus 8n plus 8. Then I have minus 8n, 28 plus 8, okay, plus 36. So this is Tn, okay. And then not only that, we know that, okay, that the first difference of the quadratic equation is actually in arithmetics. We also know that we were told that it is the 12th term and the first difference that is a number in the quadratic sequence. So let's find out what term was that, what number is that. Okay, so we're looking for T12. Okay, then minus 8 times the 12 plus the 36. Minus the 8, 12 plus the 36. Then I know I have a minus 60. Okay, so T12 is actually a 60. So the next question actually says that determine the maximum value of the quadratic sequence. Okay, in order for us to determine the maximum value of the quadratic sequence, we actually have to define the x vector. Okay, so we have our sequence that Tn was equal to an squared plus bn plus c, and then we know that we had a minus 4n squared plus 40n plus c. Okay, this was our Tn. Okay, and then we need to determine the x vector, which is says to be minus b over 2a. Okay, then we know that our a is a minus 4, our b is a 40, and then our c, okay, this was a 36. Okay, our b is a 36, our c is a 36. So we put it into here, then we have a minus 40 over 2 minus 4. So we have 40 divided by 8, then we have x is equal to 5. Okay, so since it says to determine the maximum value of the quadratic formula, in order for us to get the maximum of the quadratic formula, value of the quadratic formula, we have to take the value of x back into this formula here and solve for Tn. Okay, so we know that x or n, okay, we can call this n, which is equal to 5. Okay, so in order for us to determine Tn, we just have to take the value of n back into the formula. Which we get Tn is equal to minus 4n squared plus 40n plus 36. Then we know n is equal to 5, so substitute it equal there. Tn is equal to minus 5 squared plus 40 times 5 plus 36. Okay, then you can just put it through the form, the calculator, plus 45 plus 36. Then we know that the answer that we get here is 136. So Tn is equal to 136. Okay, so this is the value of Tn in which the quadratic will be a maximum. Okay, hopefully you guys find this video very useful. Please don't forget to like, comment, and subscribe. Share the video with your friend, and we're gonna do the next part on the next video. Okay, bye.